Hello guys, and welcome back to my next video. Today I'm going to be showing you guys the Monty Hall Problem, which is a famous game show problem where you, the player, have three doors in front of you, and behind one of the doors is a brand new car, and behind the other two doors are goats. And the host, who knows where the car is, asks you, which door do you want to pick? So you say, let's pick door one. And after you pick a door, the host always has to open another door to reveal a goat. Now, the host knows where the car is, so obviously he's not going to open up the door where the car is. So he opens up a door to reveal a goat, and he asks you, would you like to switch your door? So let's say you have door one, and the host opens door three to reveal a goat and says, do you want to switch to door two? And it's up to you whether or not you want to switch. Statistically, it is shown that switching is the better option. Why that is, we're not going to get into that because I'm just here to show you what the program is. So we're going to start by making our scanner object system.in and making a random object. And I'm going to show you guys why we're going to need this random object in a sec. And the first thing that we need to do is make our variables, which are int computer door and person door. The first thing that we need to do is generate a random door for where the car is going to be. So we'll say computer door, which is the random door, equals random next int 3 plus 1. And basically what the 3 is the computer is going to generate a random number between 0 and 2, which is 3 numbers, because computers always start at the number 0, which is why we have to add 1 to whatever number it generates, so that it becomes 1, 2, or 3, which obviously represent the doors. So now that we have a door, the car is now behind the door. So now what we have to do is ask the user, which door would you like? So we're asking the player on the show, which door do you want to pick? And he's going to say 1, 2, or 3. And then we're going to scan that into person door. Scan.nextInt. And now what we have to do is we have to check to see all possibilities for the outcome. And what I mean by that is we have to compare the person door to the computer door. We have to compare what door the person picked to the door where that the car is behind. So if computer door equals 1, I actually typed and right there, and person door equals 1, which basically means if the car is behind door 1 and the person selected door 1, then the host, the print line, the host is going to open door 2, switch to door 3, and we're going to have to scan that in. So string switch door equals scan.next. And the reason why it's scan.next is because you're only entering in a character, like yes or no, y or n. So I'll just put yes or no here. So we're going to have to do another if statement. If switch door dot equals yes, which means that the player says, yes, I want to switch to door 3, then person door now equals 3. Okay, now we have to do even more if statements. So now we say if computer door equals person door, which means if you switch and the car was behind that door, if you switch to door 3 and the car is behind door 3, then print line, I'm going to say you win. Okay, and then say else, oh, that is in all caps still, else, that print line, you lose, with a sad face. So I think what I can do, instead of having to type this out every single time, I can just copy and paste every single outcome so that anything that happens in the game, whatever door you pick and whatever car, whatever door the car is behind, it'll always work. So, oh wait, one thing that I did not do is check to see if the person did not switch. So else if switch door equals no. So let's say you pick door 1 and the host opens door 2 and he asks you, do you want to switch? And you say no, I want to stay with door 1. This is what I'm doing right here. I forgot to do this part. Then we have to check again to see if the computer door equals the person door. And if you don't switch and the door is behind number 1, then you win. Or the car is behind number 1, then you win. And if you else let's see, system.out.println, you lose. Okay. Oh. Okay. So now what I'm going to do is take all of this and just make a bunch of outcomes. So paste that again. So if computer door equals 1 and person door equals, or let's say person door equals 1 and computer door equals 2, then the host is going to open door 3 and he's going to ask you, or yeah, door 3 and ask you switch to door 2. And if you want to switch, then person door equals 2, else, yep, everything stays the same. Okay, so we just keep doing this. If the person has door 1 and the computer door has door 3, then the host is going to open door 2 and he's going to say you want to switch to door 3. Yep, person door equals 3, that's good. Okay. And then we're just going to keep doing this over and over and over again. So if the person door is 2 and the computer door is 1, then the host is going to open door 3 and he's going to say switch to door 1. And if you want to switch, then that equals 1. Let's keep going. If the person door is 2 and the computer door is 2, then the host is going to open door 3 and it's going to say switch to 1. Person door equals 1. Okay, let's keep going. If the person door is 2 and the computer door is 3, then the host is going to open door 1, switch to 3, yes. Okay. Let's keep going. Person door equals 3 and the computer door equals 1. The host opens 2, switch to 1. And as you can see, this is a very, very long process. Let's see, 3 and 2. The host opens door 1, switch to door 2. Person door equals 2. And then the last one, person door 3, computer door equals 3. Host opens door 1, switch to door 2. Okay. And what we can put inside of every single else statement, we could put this, like the door or the car was behind door plus computer door. We could do that, but just to save time, I'm not going to do that for every single one. That's basically going through every single outcome. So what I'm going to do now is I'm actually going to run this just to see if it works. Make sure it works correctly, and come up here. Which door would you like? I will say I want door 1. And the host opens door 2, switch to door 3, say yes. And I win. Okay. And for some reason this is screwing up. That's kind of weird. Why is it saying that? Host opens door 2, switch to door 3. Host opens door 1, switch to door 2. Okay, so we have a bit of a problem. So it's asking us twice. I think the reason why is because these are not else if statements. So I'm going to make every single one an else if statement. Make sure you guys do that if you want to make this program. Yeah, the only one that should be an if statement is the top one. Okay, so else, yep, this is going to take a while. And yep, that looks good. Let's make sure that's all correct. Okay, yep. It all looks good. So now we can go ahead and run it again. Let's just see if this works. This time, let's select door 3. Host opens door 1, switch to door 2. I'll say no. You lose. Okay, so it looks like the problem was fixed. Let's do door 1 again. Host opens door 3, switch to door 2. I'll say no. You lose. Okay. And then 2. Host opens door 1, switch to door 3. I'll say yes. You win. Okay. And what we could do with this is put a do-while loop in here, which would continuously ask you, do you want to play again? Do you want to play again? Do you want to play again? After every single time. And I'm not going to do that for now. I'm just showing you guys what the basics are of this. You could also make simulators that make the computer run through, I don't know, 1,000 or 10,000 different trials to see how many times switching wins and how many times staying wins and stuff like that. I can make another tutorial on that. But for now, this is just the basics of the Monty Hall problem. I hope you guys enjoyed, and I will catch you guys in the next video.